Hi, I'm Javier, and I would like to present you a note. This thing is a pedal I've been working on for the last 2 years, designing the electronics, the mechanic parts of it, the enclosure, all the software, and now that it's starting to sound nothing special, just raw input signal. I want to show you everything I've been doing to achieve this. This all started a few years ago. I was playing in a metal band with some friends, and once a week I remember we rented a rehearsal room in our hometown and we played some covers of our favorite bands. Over time we even started recording some of them and writing our own songs. I had no money for fancy amps or FX pedals, so I was playing just with the cheapest thing I could afford. And I think a lot of people of our generation can relate with this. We were raised like bedroom musicians, and especially when COVID struck, it was the common thing to do, no? Being just in your room, playing with your PC, plugging your bass or your guitar in a decent sound card. Around that time, I remember I started to listen to bands like Periphery. They had such great tones on their songs, I just wanted to sound the same like them. These guys, Misha or Nolly, had some videos mixing their instruments, and it was such a good inspiration. Seeing how without any expensive gear, just with some VST plugins you can have on your computer, you could achieve such great tones. That something clicked for me. I realized I didn't have to spend hundreds or thousands in great big amps. Just with some plugins on my PC, I could get far better tones than my poor 10 watt Harley Benton. At the same time, I was studying an electronics degree, and man, I think if you are into electronics and into music, it's pretty easy that the idea of building a pedal comes to your mind. Even Linux Torvalds, which doesn't play guitar as far as I know, it's building one.
If you want me to build something, this is what I built. I brought it for you.
We're getting show and tell?
This I built.
Hold on. Okay, let me try and figure it out. Hold on. Okay, it has a button. It has a dial. It has power.
It's a guitar effects pedal.
In November 2023, I finally decided to stop thinking about this idea and actually test it. At this point, I wasn't trying to build a working pedal. I was just doing a proof of concept. I started with a Raspberry Pi, not because it was ideal, but because it was familiar, cheap, and easy to experiment with. The big question was, can I actually run the same plugins I use on my PC on something like this? Most guitar plugins are VSTs, and VST plugins are usually built for Windows or macOS, running on x86 CPUs. But embedded boards like the Raspberry Pi are very different machines. They usually run Linux and they use ARM processors. Different operating systems, different CPU architecture. So out of the box, those plugins simply won't run. On Linux, there's a well-known compatibility layer called Wine. It allows Windows applications to run on Linux. That solves part of the problem, the operating system side, but it doesn't solve the CPU problem. x86 plugins still won't run on an ARM CPU. For that, you need some form of emulation or translation. There's software like Emu that can do this. It translates x86 instructions into ARM instructions. The problem is performance. For real-time audio, that approach is usually too slow. In theory, the best solution will be to recompile the plugins for ARM and Linux, but in practice, most commercial plugins are closed source. You don't have the code, you cannot rebuild them. That's when I started experimenting with something called Box64. It's mostly used for running x86 games on ARM systems. It works by translating instructions dynamically at runtime. Specifically, it performs dynamic binary translation at the instruction level with direct mapping to native system calls and host libraries, whereas Qemu primarily relies on full system emulation, which takes more CPU. And surprisingly, it worked. I actually managed to run some basic VST plugins on the Raspberry Pi, and that was a huge moment. But the latency was terrible. There were two main reasons. First, I was using an x86 compiled audio host, which meant even more CPU time spent translating instructions. I needed an open source plugin host that I could compile natively for ARM, so the CPU was only translating the plugin, nothing else. Secondly, the audio stack I was using at the time wasn't designed for real-time audio under this kind of translation. Box64 audio handling just wasn't built for low latency signal processing. And finally, despite the CPU load still being way too high, it worked. I got sound with latency I could live with. So the idea was not impossible, I just needed some optimizations and a much better foundation. That's what made me do the next prototype. Basically, I had this question. What will be my ideal pedal if I was the user? I want it to be flexible enough to work not just with guitar, but with pretty much any instrument or signal. So I decided on a 2-channel audio input using XLR TRS combo connectors to support mono or stereo sources. On the output side, I wanted stereo jack outputs, a dedicated headphone output, and balanced XLR outputs. I also added MIPI in and MIPI out or through, an expression pedal input, and a USB-C connector. The idea with USB-C was twofold: use the pedal as an audio interface, and potentially power it through USB if power delivery allows it. Then there was the user interface. Since the whole idea of this pedal is running plugins, I didn't want to recreate a traditional pedal full of knobs. Plugins are designed to be used on computer screen. They have complex interfaces, meters and graphs. With this in mind, I needed a color screen, relatively large, and with a touchpad of course. That's why I decided just to put 4 stump boxes in the front. I don't have them now, but I will add several encoders to the front panel of the pedal. Once I had the constraints clear, I started looking for existing open source projects related to audio hardware. One project I found was Mod Audio. They are a pedal company and a lot of their work is open source. They have, for example, the Mod Wharf, which is actually quite close to what I wanted to build, a pedal that can actually load plugins. But when it came to hardware design, my biggest inspiration was Thintian. Thintian is an open source instrument based on Raspberry Pi, running a custom Linux distribution optimized for audio. Its mainly used for synthesizers, but I thought the electronics were pretty similar to mine. It also has analog inputs and outputs and MIDI, so I used part of their designs as a starting point for my electronics. I really like Thintian, being honest. It's pretty easy to work with because, for example, here you have all the audio hardware, but also if you're playing with a Raspberry, for example, which is my case, you have here the GPIO expander connector. If I'm using, for example, any other board and I want to test some GPIOs or an audio interface like IS2, you just have to connect some cables here. It's pretty easy. From there, I started working on the schematic. One of the parts that worried me the most was the high-speed interfaces. Things like USB-C with power delivery and the display interface. These buses run at very high speeds, and if you don't route them correctly, differential pairs, impedance matching, you can get signal integrity or REMI problems. The scary part is that if something goes wrong, I don't really have the equipment to debug it, because my oscilloscope and the logic analyzer I have are kind of cheap, not fast enough for this kind of signal, so if it fails, I'm absolutely lost. I will have to redesign the board and it will be a pain. About the mechanical part of the pedal, almost everything was revolving about the 8 inches touchscreen. You can see you have the screen and almost nothing else, some margins and that's all, without it being too bulky and then trying to fit the PCBs and all these kind of things inside. I used open source tools, KiCad for the electronics and FreeCAD for the mechanical design. KiCad was fine, but FreeCAD was painful. Every time I changed something in the PCB, connector position, border line, mounting holes, synchronizing that with the enclosure was a mess. Once I had the first revision ready, I 3D printed the enclosure in PLA and ordered the electronics. Every time I had to order PCBs with the assembly and the main board and the encoder board and everything I needed was almost like in the 500 euros range. So yeah, that was the time where errors were getting pretty expensive. And when the board arrived, a lot of things were wrong. I miscalculated some resistor values in a power multiplexer, so power wasn't being routed correctly. While trying to fix that, I created a short and killed a compute module. At first, I thought the issue was with the UARTdebug interface, but later I realized that some resistors selected in the boot mode were incorrectly configured. That information wasn't clearly specified in the vendor documentation. Some resistors were overlapping with enclosure mounting holes. The touchscreen support wasn't rigid enough, so the screen was actually moving inside the case. At that point, the first version of the PCBs and the enclosure were basically unusable. There was not any other way around. I had to start working on Prototype 2. Prototype 2 was all about fixing mistakes, not adding new features, just making the original idea actually work. One of the first things I changed was the control section. In the first prototype, the switch encoder wasn't just strong enough to be used as a foot switch. So this time, I went with proper foot switches from a dedicated supplier and redesigned that part completely. Since the encoders were now independent, I moved them to the front of the pedal since I had some room. That decision alone meant redesigning an additional PCB and the wall enclosure. The objective was to power the pedal either from a standard DC jack or from USB-C, automatically selecting the best source at runtime. Also, the pedal should be able to provide power to the connected devices over USB. I did run into some issues here, but nothing as critical as in the previous prototype. This time problems were solvable. Then came the touchscreen. This is a core part of the pedal. If the screen doesn't work, the whole concept falls apart. Unfortunately, the documentation from the display provider was not great. Some signals were described as optional in one place, but the driver actually expected them to be present. One example was a synchronization signal in the video interface. That single issue cost me almost a month. I ended up reading the display controller datasheet register by register and digging through the Linux driver code. But eventually, I got it to work. Finally, the most important part, audio. I had to really understand how the Linux audio stack works, how the codec driver interacts with the machine driver, how I2S signals are configured, and how everything is clocked. I ran into some issues with master-slave clocking. Some clock configurations just aren't supported on all the interfaces of the compute module, and I didn't saw that coming. Getting the ADC, DAC, and headphone amplifier to work all together took time. I finally got clean audio from my guitar into the pedal to my monitors. No plugins, no effects, nothing, just raw audio. And after 2 years, that felt huge. So at this point, the pedal does one of the most boring things, but also one of the most important. It boots, the screen works, audio goes in and out with low latency, and the assembly of the case and the electronics works fine. I'm finally at the point I wanted to get to. The hardware part was driving me a little crazy, breaking stuff, wasting hundreds of euros replacing PCBs and components, finding suppliers, waiting for the electronics production and shipping. So what's next? The first obvious step is running open source audio plugins. There's already a huge ecosystem of free and open source effects and instruments for Linux. I also want to try some amp modelers like AIDA-X. And finally, like I did on my first Raspberry Pi prototype, see if I can get BST plugins running on it. But for now, I'm not going to demo any of this yet. One thing I want to be clear about is why I'm sharing all of this. I could have waited until I had a more polished demo, but it came a time that after a little bit more than 2 years working on this, I just want to know if people feel this idea appealing, if you would like to have this pedal, if it's worth for me to work on this on a more professional manner, trying to do a crowdfunding and even sell it in the future, or just to keep it as a hobby. So this video has been basically about the past, but if you're interested, feel free to subscribe, because in my next video I'm pretty sure I will try to install some open source plugins in it, and instead of having just a clean DI signal on the guitar, we will start to hear some effects in it. So if you want to keep up with the project, apart from subscribing to the channel of course, you can go down below to the description of this video, because you will see a link where there's a landing page. I get to run BST plugins on it. I do something interesting about Node, or even I do a crowdfunding or whatever, I will send you an email so you can keep more updated with the development. And I promise no spam at all. I will just send you interesting stuff. And that's all for now. Bye.